Assalamualaikum and good morning to all 4B students. So today you will learn 3.4 chemical equation, the last subtopic in chapter 3. Okay, so these are the steps on how to write chemical equation. Okay, so we have an example here. So the first step is you write the equation in words. Okay, so for the reactants, okay, you write hydrogen plus oxygen. Okay, for the product, okay, water. Okay, so second step, write down the chemical formula of each reactant and product. Okay, so you write for hydrogen H2 plus O2 and then the product is H2O. Okay, the third step, you check whether the equation is balanced. Okay, so you have two hydrogen atoms here and two atoms of oxygen. Okay, and the product here we have two hydrogen atoms and one atom oxygen. Okay, so you can see here the oxygen atoms is not balanced. Okay, the reactants we have two atoms of oxygen, but for the product we have only one. Okay, so equation is not balanced. So the fourth step is you have to balance the equation, okay, by adjusting the coefficient in front of the chemical formula. So you look at the product, okay, you have only one atom oxygen just now, right? So to make it 2, you put 2 as the coefficient in front of it. So meaning now hydrogen 2 times 2 you have 4 hydrogen atoms, and oxygen 1 times 2 you have 2 atoms of oxygen. Okay, so for the oxygen it's balanced. Okay, but for hydrogen you have to put 2 as a coefficient, so that 2 times 2 becomes 4 hydrogen atoms. Okay, now all are balanced. Okay, now you see for hydrogen we have 4 here for the at the reactants and 4 atoms at the product. Okay, for the oxygen also balanced 2 and 2. Okay, so the final step is you write the physical state of each reactant and product. Okay, the physical state is like for the hydrogen you put gas. Okay, in the bracket gas, oxygen also gas, but the product is liquid, so you put L. Okay. Okay, so there is one experiment, okay, in this subtopic, which is a 3.18, activity 3.18, to write balanced chemical equations. Okay, so we will do this in school. Okay, using chemical equations. Chemical equation can be interpreted qualitatively and quantitatively. From the qualitative aspect, chemical equations enable us to identify the reactants and products as well as their physical states. For example, the reactants here are sodium metal and chlorine gas, and the product is solid sodium chloride. Okay. From the quantitative aspect, we can study the stoichiometry of chemical equations. Stoichiometry is the quantitative study of the composition of substances involved in a chemical reaction. Coefficients in chemical equations show the ratio of substances involved either as the ratio of elementary entities of substance or the mole ratio. So take a look at the following example. Okay, so this one is coefficients in terms of ratio of basic entities, which is particles. Okay, so you look here. Okay, 2 sodium atoms react with 1 molecule of chlorine, okay, to produce 2 sodium chloride. Okay, so the second one, this one is coefficients in terms of mole ratio. Okay, 2 mole of sodium react with 1 mole of chlorine gas to produce 2 mole of sodium chloride. Okay, based on the mole ratio of substances from a balanced chemical equation, we can solve various numerical problems by calculating the number of moles of substances required in the right ratio. Okay, so for example, okay, the initial mole ratio is like this. Okay, 2 mole, 1 and 2. And then if all values are divided by 2, you will get 1 mole here, 0.5 mole and 1 mole. Okay, so you can divide and multiply, depends until you get the right ratio for other values. Okay, so example 17, this is example from your textbook. Okay, burning of aluminium in air is as follows. Okay, so this is the chemical formula. Okay, what is the mass of aluminium oxide produced if 5.4 gram of aluminium is burnt completely in air? So given the RAM for oxygen is 16 and for the aluminium is 27. Okay, so let's look at the solution. Okay, so you analyze the question and this is the solution plan. Okay, so the equation is this. Okay, 4 aluminium plus 3 oxygen and it produce aluminium oxide. Okay, so the information from the equations, for the aluminium there is 4 mole, and then for the aluminium oxide 2 mole. Okay, and information from the question, the mass of aluminium is given 5.4 gram. Okay, so you have to find the gram for aluminium oxide. Okay, because the question is what is the mass of aluminium oxide, so meaning you must find the gram of aluminium oxide. Okay, so to find the gram you must find the ratio first. Okay, the mole ratio, so you find the mole ratio for aluminium. Okay, so we look at next solution, next step. Okay, so the number of moles in aluminium is, okay, you draw the formula. Remember the formula in 3.2. Okay, involving mass and moles. Okay, so this is the mass and this is the number of moles and this is molar mass. Okay, so to find the number of moles, okay, here what you do is mass divided by molar mass, because mass is up here, molar mass is down here, so mass divided by molar mass. Okay, so mass is given 5.4 gram, the molar mass is equal to the RAM, relative atomic mass 27, so after you divide you get 0.2 mole. Okay, now you have to find the mole for aluminium oxide, then only you can find the mass. Okay, so as you can see here, okay, the solution is they write for you. Okay, let me explain in number, in proportion method. Okay, so meaning like this is aluminium, okay, and this is aluminium oxide. Okay, from the equation 4 moles reproduce 2 mole for aluminium oxide. So if 0.2 mole, how many mole here? So by doing simple calculation, 0.2 divided by 4 times 2, you will get 0.1. Okay, so the answer here is 0.1. Or you can do like this, 4 to become 2 divided by 2. Okay, so 0.2 also you can divide by 2, so you will get 0.1. So 0.1 is the number of moles. Okay, number of moles for aluminium oxide. So to find the mass, what we do is moles times molar mass. Okay, according to the formula. Okay, we have the moles here. Okay, to find the mass, moles times molar mass. So this is the solution. Okay, the number of moles times molar mass. Okay, for the aluminium oxide. Okay, so 0.1 mole times with the molar mass. Molar mass is you plus all the RAM. Okay, according to the formula. Okay, according to the formula, the formula is Al2O3, right? So 2 times aluminium 27 plus with 3 times the oxygen 16. Okay, and then after you calculate, you will get 10.2 gram. So this is the answer for the mass of aluminium oxide. Okay, so we have finished our chapter 3. Okay, so please do this exercise. Okay, textbook page 70, activity 3.17 number 2. Textbook page 74, you do activity 3.20 number 234. Textbook page 74, test yourself 3.4. And then please complete chapter 3 in your workbook module A+. Okay, so please let me know if you don't understand any of the questions. Okay, okay, thank you. See you next class.